Okay, so today we have the last topic of our course, which is normal approximation to the binomial. So what this allows you to do is all the binomial problems that we've learned how to do using binomial PDF and binomial CDF. If I took away your calculator, how would you do it? You'd have to resort to normal theory methods. So bear in mind that the binomial distribution is discrete, but we're going to be using normal theory methods to approximate the binomial. Okay, let's start with a problem. Let's say that n is equal to 100 trials. If you don't want to take notes, you don't have to, because I'm going to be posting these notes and the video. So that's up to you, okay? Let's say that n is 100 trials and p is equal to 0.75. And here's the question. Find the probability that r is less than or equal to 70. Find the probability of less than or equal to 70 successes in 100 trials. You already know how to do this by binomial methods, correct? How? Let's do it. Let's do it, and then let's approximate it also. So A, exact answer. So the exact answer to this is binomial CDF N P 70. Agree? It's CDF for cumulative, meaning I want the probability of 70, 69, 68, all the way down to 0. So can you get me this answer, please, on your calculator?
No, 1495.
0.1495. Agreed. So that's your exact answer. Now I want to approximate it with a normal curve. Okay? So B, normal approximation to this binomial. So as long as NP is greater than or equal to 5 and NQ is greater than or equal to 5, then your discrete binomial can be approximated by a normal curve. And of course the normal curve is continuous. So what I'm trying to say is this. You have some discrete distribution like this. And instead of doing this by discrete methods, because I'm going to be confiscating the calculator, you're going to approximate it by a normal curve such as this. So as long as NP and NQ is each greater than or equal to 5, these errors, these things that I'm shading right now, are the errors. These errors will be small, providing that these conditions hold. However, you must make a continuity correction. So look what I mean by that. I'm interested in the bar for 70. Remember, this is discrete. So I have a bar for 70 and a bar for 69 and so on, all the way down to 0. And the exact answer would take the sum of all these probabilities, all this stuff, all the way to here, to the bar for 70. That's what I'm interested in when I say r less than or equal to 70. However, if this is some curve like this, then you see that this bar actually ends at 70.5 because this bar for 70 stretches from 69.5 all the way to 70.5. So if I'm going to use normal methods to do this, then this bar all the way up to and including 70.5 is where I begin and I sum left. So I want to say probability r less than or equal to 70, where r is discrete, is equal to probability x less than or equal to 70.5, where x is continuous. Are you with me? So I'm saying that I better sum all the way to 70.5, not just to 70, because if I didn't, then I would be off by this much. I would be off by that much if I didn't do that.
If it turned out that NP was less than 5,
Then you have to do it by NCR, P to the R, Q to the N minus R. You cannot approximate by a normal curve. So this approximation where the errors are tiny only works if these two conditions hold. And if they don't, then you have no right to use normal approximation. Okay, so now that I want to do this, I'm almost done. This is a continuous normal distribution. That means that if I know its mean and its standard deviation, I could clean up this problem and be done. So how about finding the mean of this distribution? Mu equals n times p for a binomial. We know that, right? Mu equals np. So n is 100, p is 0.75. So this is 75. And sigma equals rad npq. So that's rad 100 times 0.75 times q, which is 0.25, because remember p and q add up to 1. So that turns out to be 4.33. And I'm almost done. Look, probability z less than or equal to 70.5 minus the mean, 75, divided by sigma, 4.33. So that's probability z less than or equal to minus 1.039. We're going to round that to minus 1.04. Then I go to my z table and I look up minus 1.04 and I see 0.1492. And I'm done. That's my answer. That's my answer by approximation. So the error, absolute value of the error, is equal to 0.1492 minus the exact answer. The exact answer used to be 0.1495. I did that up on the top. So 0.1495. My answer, 0.0003. Imagine you're only off by 0.0003 and you didn't even use discrete methods. You used a normal curve to approximate this probability. Get it or no? Cool, right? So let's label this normal
You can still use
approximation.
the calculator on the final?
Can you use a calculator?
On the
Yeah,
final?
yeah. course. Yeah. Yeah. No, I'm not really going to take it away. Okay, next problem. So now we can do all these problems in here, whichever problem you want to do. Let's go here and put some of this stuff in. So it says here, this is on the first page of this typed lecture notes, right? Firstly, the theorem says if NP and NQ is greater than 5, then we can approximate this distribution by a normal curve. So these are the important things, right? Mu equals NP, sigma equals rad NPQ. The conditions will guarantee that the distribution is bell-shaped, unimodal, symmetric. In general, as n gets larger, the approximation gets better. Continuity correction is talking about the fact that the whole number 2 actually stretches from 1.5 to 2.5. So in my problem here, let's go to this problem for a second. And let's say that the question was part C. Find the probability that x is equal to, sorry, not x, r. I have to be very careful with that because r is discrete, x is not. So find the probability that r is equal to 70. If this was the question, then the exact answer would have been binomial PDF. N P 0.75 and R, which is 70. Notice I'm doing PDF because it's exactly 70. So what do we get for this one? If you could stick that in the calculator, NPR. 100, 0.75, and 70. Point 0.0458.
Or 8, because 5 happens.
Okay, 0.0458. That's the exact answer. I want to do this by continuity correction and normal approximation. So,
I didn't get that answer.
what did you get?
I have 0.0020.
So, can somebody confirm this answer?
Yes, you can confirm.
You got 0.0458?
Sorry, I did.
Okay, so C
Yeah, true.
by redone by normal approximation. So we already know that NP is greater than 5 and NQ is greater than 5. So I can go ahead and approximate this with a normal curve from, here's the bar, 70, from 69.5 to 70.5. Agreed? Through the bar for 70 and that bar stretches from 69.5 to 70.5. Agreed or no? So this will be probability x goes from 69.5 to 70.5. And let's clean that up. Probability 69.5 minus mu. Mu was 75 divided by sigma 4.33 less than z less than 70.5 minus 75 over 4.33. All I'm doing is changing the x to z because I already know that x is normal with mean mu and standard deviation sigma. So I have the right to change it to z. Okay, so what do we have here? Let's do it. $69.5 minus 75 divided by 4.33, negative 1.27.